Hello and welcome back to my course in probability theory. Now, in the first class on probability theory, which we have discussed, we have given you the concept of random experiment, which I think is the most important part of theory of probability. And by this time, I think you have understood the concept of random experiment because it is the base of probability theory. So, if we are clear with the concept of random experiment, now we can go to another concept, another important concept of probability theory, which we call it by the term events. Okay, so now the thing is that what are actually events? Basically, you can say in one word, that is, events are nothing but the outcomes or results of a random experiment. So the random experiment that you have learned in the first class, you have seen that there are some outcomes or results of that random experiment. So those outcomes or results of the random experiment are actually called events connected with the experiment. So let's say one example. Let's say in the case of tossing a coin, if you toss a coin, you know there are outcomes. Of course, the outcomes are, as you all very well know, they are a head and tail. So a head is an event in the experiment of tossing a coin. Tail is also an event in the experiment of tossing a coin. Okay, now how we denote an event? We basically denote an event by any capital English alphabet, and the description of the event is written within the single quotation. So for example, if I want to write the event, let's say head, so how do we write that? For example, the event head is written as A, then we write a hyphen, and then we write within single quotation the description head. So in my problem of probability, this A will actually signify that it is an event head in the experiment of tossing a coin. So that is the way we actually denote our event normally. Okay. So then we actually come to the classification. There are actually two types of event. One is called a simple event and the other one is called compound event. There are two types of event, basically simple and compound. Now, when do we call an event simple and when we call an event compound? Now, that I will explain with a simple example. That will be easier for you to understand. Okay. So coming to this example, so let's say what we do is that we consider a random experiment. We consider a random experiment of rolling a die, and we define an event there, which is an odd phase. Just like the way I told you that we can denote a event by a capital English alphabet and write within single quotation its description, which is odd phase. So as you all know, odd phase will have 3 possible outcomes out of the 6 possible outcomes, and they are 1, 3, and 5. So we have written that. Now we notice that there are several things we can notice here. We can actually decompose this event 1, 3, and 5 further into the events 1, 2, and 3. Because you know that 1 is also an event because getting the phase 1 is an outcome of the experiment of rolling a die. Similarly, 2 is also an event, 3 is also an event because they are results. So the event 1, 3, and 5, which comprises odd phase, can be further decomposed into the events 1, 2, and 3, right? But you see that, can you decompose the event 1, 2, and 3 further? No, you can't do that. Under the experiment of rolling a die, we cannot decompose this event 1 or 2 or 3 further. So the events which you are not able to decompose further, which are these 1, 2, 3, under this particular example, they are called simple events. The events which cannot be further decomposed, and the events which can be further decomposed, which is the event odd phase here 1, 3, and 5, are actually called compound events. So here you see odd phase is an event, and 1, 2, and 3 are individually also events. But there is significant difference between the two, because in this case 1, 3, 5, which we told earlier, that we were able to decompose this event further into 1, 2, and 3, because these are also individual events, getting the phase 1, getting the phase 2 or 3. But you cannot decompose 1, 2 and 3 further. Can we? We can't. So events which cannot be further decomposed are called simple events, and the events which can be further decomposed are called compound events. So that's what are the two things I have written down, and that is the way we distinguish the two ways of representing an event in the experiment of rolling a die or any type of experiment that you can say. So what we do is that we say that, yes, as I was saying you, the same thing I have written here. You can see on the slide that 1, 2 and 3 are simple events over here. This 1, 2 and 3, as I was telling you. So 1, 2 and 3 are simple events, while the odd phase that we have taken earlier is actually a compound event, because that was that we were able to decompose further. Okay. So we have the following observations from the previous example. What we have the following observations. The first observation that we have, if you have understood this concept of simple and compound events, you actually see that any outcome of a random experiment is a simple event of that experiment, because in the previous example also, which we took in the experiment of rolling a die, we decompose the event odd phase into 1, 2 and 3. Now what are these 1, 2 and 3? They are individually outcomes of a random experiment. 1 is outcome, of course, 3 is outcome, 5 is outcome. So you see basically 1, 3 and 5, which we call it as simple events, as we have already said, they are actually outcomes of a random experiment. Similarly, if we had taken the example of even phase, which would have comprises 2, 4 and 6, we could have easily decomposed them individually into 2, 4 and 6, and therefore 2, 4 and 6 are also simple events, because they itself cannot be further decomposed. And then what are these 2, 4 and 6? They are also outcome of a random experiment. So we can come to this conclusion that any outcome, this is a very important observation, any outcome of a random experiment is actually a simple event of that experiment. Okay, so let's say in the example of tossing a coin, there are two simple events. One is head, the other one being tail. Okay, in the example of drawing a card from a full pack of playing cards, there are 52 outcomes. Each one of those outcomes is a simple event. So any outcome of a random experiment is actually a simple event of that experiment, right? So if that is so, then we can come to this statement: the number of outcomes of a random experiment, is equal to the number of simple events of that experiment. And that is very always true. The number of outcomes of random experiment is always equal to the number of simple events. That's what we have observed just now, and we have explained also. So like in the case of tossing a coin, there are two simple events because there are two outcomes. In the experiment of rolling a die, there are 6 simple events because there are 6 outcomes. In the experiment of drawing a card from a full pack of playing cards, there are 52 simple events, and because there are 52 outcomes. So each one of the outcomes is a simple event, right? That's a very important observation. So the number of outcomes of random experiment is equal to number of simple events of that experiment. That is a point you should always keep in mind. And then we can say in the reverse manner that if you can take an aggregate of two or more, minimum 2, right? 2 or more simple events, we get what is known as a compound event. That's another way we can define. I mean, instead of saying that a compound event can be further decomposed, we can say from this point that if we aggregate 2 or more simple events, at least 2 of course, then you get what is known as a compound event of that particular random experiment. Then we come to some special types of events, and that's very important. These are very basic things, but very important as far as probability theory is concerned. So we come to the concept of the first one of that is the certain event. As the name says, certain. Certain means basically something which is sure to occur, which will definitely occur, because events are basically outcomes or results of an experiment. So what are certain events? As I was saying, an event which is sure to occur at any particular performance at any performance, not a particular, sorry, at any performance of the experiment. So it's like that basically when you are performing the experiment, every time that event is occurring, every time, let's say you have performed that experiment 50 times, each of those 50 times the event has occurred. such a event is called a certain event. Now some examples, you see in the experiment of rolling a die, if I have defined the event in this manner, see I have written in single quotation the description 1 or 2 or 3 or 4 or 5 or 6. So I have separated the outcomes by OR. Now you see, if you perform the experiment, okay, if you perform the experiment however number of times, every time you see this event will occur, because the way that you have defined, you have actually considered all the possible outcomes of the experiment here. And since you have considered all the possible outcomes of the experiment here, every time this event is going to occur, because you are bound to get anything from 1 to 6 if you roll a die. In the experiment of tossing a coin, I will write within single quotation head or tail, because if you toss a coin, you are bound to get either head or tail. So head or tail will definitely come at however number of times you just toss that coin. So those events are actually called certain events. Certain means something which is sure to occur, which will definitely occur. Okay, the chance is 100% chance. Then we come to what is called impossible events. As the name says, impossible. Impossible means something which is not possible logically. You have defined an event, fine, no problem, but that event is not possible logically. Like say, basically if you consider the example of let's say in the experiment of rolling a die, we have defined the event 7. Now that's 7. If you write, you can always write or define an event with respect to an experiment. But do you think logically is it correct? It's not, because you see that 7 you'll never get, because you know very well if it's unbiased die, the dice are the faces of the die, 6 faces are marked 1, 2, 3, 4, 5, 6. So there are 6 possible outcomes. So you will not get the face 7 if you roll an unbiased die. You will never get it. So that is something which is not possible. Or let's say I just put it in a different way. Let's say in the experiment of tossing a coin, I write the event head and tail. If I write head and tail, just I replace or by and. If I write or, it becomes certain. Now or is replaced by and, ampersand. In that case, it becomes impossible. Because why? Very simple. Because you are not expect to get head and tail simultaneously if you toss a coin. That is physically absurd. So those events which are not possible logically, I mean, are actually classified as impossible events. As from the name you can find out it's why it's not possible logically. So these are two special types of events. We get certain events and impossible events. Now moving further, we come to another important type of event. Very important, I will tell you, because this plays a very important role later on in the discussion of theory of probability, and it's called mutually exclusive events. What are mutually exclusive events, right? Now this I'll explain with a very simple example. Okay, so the example that I've taken is that we have considered a random experiment of rolling a die, and there we define 3 events. First we have defined the event A as odd face, which comprises 1, 3 and 5. Then we have taken the event B as even face, which comprises 2, 4 and 6. And we have taken a third event, C. See, the description is written multiple of 3. That is all multiples of 3 in the experiment of rolling a die. So of course, the only 2 will come, 3 and 6. Out of the first 6 natural numbers, 3 and 6 are the 2 natural numbers which are multiple of 3. So these 3 events we have considered in the experiment of rolling a die. And what we observe is that, let's see what we observe. The first thing that you see that we observe is that if you now out of these 3 events, how many pairs you can find? You can find 3 pairs. First pair we consider is that A and B. We consider these 2 pair A, and we consider the pair the event B. So that makes up a pair AB. The other 2 pairs of course are AC and BC. We will consider that later on. First we consider the pair AB. So if you consider the pair AB, you see that we have written their outcomes right on this side, and you see that is there any outcome common between the 2 events? No, they have no common outcome of occurrence. Now if you find that there are 2 events which have no common point of occurrence or common outcome of occurrence, then they are, so they will then there's no possibility of those 2 events to occur simultaneously. Will they ever occur simultaneously? No, they will never occur. So in those cases, the events are called mutually exclusive events. Like in this case here, A and B are mutually exclusive because you see that the events A comprises of 1, 3 and 5 and the event B is 2, 4, 6. So basically A and B are mutually exclusive because in no way A and B will occur simultaneously, and that we also know from the basic concept of mathematics that odd numbers and even numbers are distinct. So if you roll a die, you're bound to get either an odd number or an even number because we know that the first 6 natural numbers are my outcomes. So it's not possible to get odd and even simultaneously, and that gives you this knowledge that they will never occur simultaneously, and if they do not occur simultaneously, I will say that two events are mutually exclusive, right? But let's come to the second observation that we find. If you consider the other two pairs, let's say I consider the pair A, that is odd face, and the C and multiple of 3, right? So odd face comprises of 1, 3 and 5. Multiple of 3 comprises of 3 and 6. Now if you compare A and C, you see what you see. There is one outcome, 3, is common to both A and C, right? Right? So do you think they will occur simultaneously? Yes, of course, they have a chance of occurring simultaneously, because if you roll a die and let's say you have got the face 3, then you have got an odd face as well as you have got a multiple of 3. So you have got an odd face and multiple of 3. So since you have got odd face and multiple of 3 simultaneously, so there is a chance of occurring simultaneously, and hence they are not mutually exclusive. The same thing goes with the other pair. If you consider the pair B and C, you see that in this pair also, okay, there is one event point that is common to both, that is 6. You see, B is even face and C is multiple of 3. So if you perform the experiment and let's say you have got the phase 6, then it means that you have got even phase, and also you can say that at the same time that multiple of 3 has also occurred. So both have occurred simultaneously. So there is a chance that of occurring simultaneously occurs. So that means the event B and C has a chance of occurring simultaneously. So that means they are not mutually exclusive. So the pair A and C and the pair B and C are not mutually exclusive because they have a possibility of occurring simultaneously. So only the pair A and B are mutually exclusive here, because that is the only pair which has no way of occurring simultaneously. So we can say the definition now. Thus, two events are mutually exclusive if they cannot occur simultaneously. So if they can occur simultaneously, they are said to be not mutually exclusive. So two events, so that's the definition. So two events are mutually exclusive if they cannot occur simultaneously, right? So I think you have got this concept. So now we come to a very important question now. The question is, do you think that two simple events are always mutually exclusive? That's the point, because we have just now discussed what are simple events and compound events. So this question has been put up to you, that do you think that two simple events are always mutually exclusive? Think about it. Answer is yes. Two simple events are always mutually exclusive. No doubt about that. I'll explain you why it is so. This is so because as discussed earlier, we have just now discussed earlier that any outcome of a random experiment is a simple event connected with that experiment, right? Now, since any outcome is a simple event connected with the experiment, you very well know that if you perform an experiment, you are bound to get only one outcome out of the possible outcomes that you know. You are not you don't expect to get two outcomes simultaneously. Like in the case of rolling a die, if you roll a die once, do you expect to get 5 and 6 simultaneously? No, that's the absurd thing that you're thinking of. You will get either 5 or 6, or maybe you can get any of the remaining 4 outcomes. And that explains the fact that why two simple events are cannot occur simultaneously, because simple events means outcome, and you very well know two outcomes cannot occur simultaneously. So therefore, two simple events are always mutually exclusive to each other because they have no way of occurring simultaneously. That is a very important observation. So from the above example, we come to this conclusion that what we can conclude? We can conclude that two simple events are always mutually exclusive, but compound events may or may not be so. So why we say that for compound events? Because the example that I have taken, you see the example that I have taken in the previous slide here, right over here, you see all these three were what? These three were compound events. All these three were compound events, right? And we have just now found that this pair was mutually exclusive, AB, whereas the other two pairs were not. So you see, in case of compound events, we cannot say that, but we can definitely say that in case of two simple events, right? So that is a very important observation. Two simple events are always mutually exclusive, but compound events may or may not be. So we cannot say with surety that these two compound events are always mutually exclusive. It may happen sometimes, it may not happen sometimes. Okay. So with that, I come to the end of today's class. So I hope you have understood the concept of this events and some special types of events. So in the next class, we'll be discussing on another very important concept, which is called sample space, because the sample space plays a very important role in the further discussion of probability. So thank you all for your patient hearing. We meet in next class with the concept of event space. Thank you.